Hello and welcome to part 1 of an introduction to high-performance computing at NC State, specifically using our HPC cluster Hazel. This tutorial is brought to you by the Research Facilitation Service in collaboration with the Research Computing and Data Department under the umbrella of the Office of Information Technology, or OIT. This video is the first of a 4-part series covering the following topics. Topics covered in this first part include the acceptable use policy, how to access Hazel for the first time and in general, and a review of basic Linux for navigating and interacting with a Linux environment from a text-based interface. Future videos will cover file transfer and storage specifics for Hazel, how to run applications using basic job scripts with LSF, as well as an introduction to parallelization and parallel jobs. So, before you log into the cluster for the first time, we ask that you read our acceptable use policy in total. I know you're probably used to the, endless gauntlet of terms and conditions that just seem impossibly large to read. However, our acceptable use policy is less than a page long and just covers how to utilize the cluster in a way that does not interfere with other people utilizing the cluster. In short, login nodes, compute resources, and storage options are designed to be used in a specific way. We ask that you learn how to use the resources the way they're supposed to be used before you utilize them, and don't try to circumvent protections that we have put in place against misuse. Finally, unresponsive compute nodes will be rebooted without notice. Essentially, we will prioritize the functionality and communication of the cluster over the completion of any individual job. Before utilizing the cluster, you will need to request an account so it can be put under an existing project. For up-to-date instructions on requesting an account on the cluster, visit hpc.ncsu.edu/accounts/getaccess.php. Once you have successfully requested your HPC account, you will need to access the cluster via a terminal, which is a text-based interface for interacting with a computer system. This can be done one of two ways. The first way is through a browser. You can open a web-based terminal through Open On Demand if you are part of the UNC system. The instructions for doing so can be found here at hpc.ncsu.edu/document/login.php. Once we get to the document/login page, we have instructions both for logging in via terminal as well as via Open On Demand. We go to the following address, log in using our typical NC State or other UNC school login. We get a quick do a push. And here we have the Open On Demand opening page. As seen here, once connected, we select Clusters and then Hazel Shell Access. Clusters, Hazel Shell Access. And we have a shell on a login node on the Hazel cluster. Alternatively, you can log into the cluster directly via a terminal on your own computer. If you're running a Mac or Linux system, you don't need any additional software. Simply use the terminal application already installed on your computer. If you need to use a graphical interface for any of your programs on the cluster, you will need to install Xcorts to allow X11 forwarding. No additional software is needed if you're using a Linux system. On the other hand, if you're using a Windows system, you will need to install a terminal emulation application. In this case, we recommend MobaXterm as your application of choice. We have instructions here for installation and configuration found under Documents/MobaXterm. Once you've opened a terminal, either through your terminal application or through MobaXterm, you will access the cluster via SSH or secure shell using the following template: SSH space your Unity ID at login.hpc.ncsu.edu. Press enter and enter your login credentials. You will be asked for a duo push. You can press 1 for a typical duo push and 2 for a text code type duo push. And as you can see at the bottom left of the screen, we are no longer logged into my work computer. We are logged into a login node, in this case login 04, part of NC State's cluster Hazel. As long as you see a similar prompt at the bottom of your screen, you're ready to move to the rest of the tutorial. So, Essential Linux. If you are already an old hand at Linux, you utilized HPC before, maybe at a different university, and you're just looking for the specifics of the Hazel cluster, you can actually skip the rest of this video. The next video goes over file transfer and storage specifics to the cluster that might be different from what you're used to, but the rest of what's contained here is just an introduction to how to navigate and interact with a Linux environment. If, on the other hand, you're used to a windowed environment, for instance, a traditional Windows or Mac We're going to move from a click and drag interaction type framework to a text-based interface. So instead of looking around and seeing where you are, you're going to have to actually enter commands and look at the results. This captures the pretty typical pattern of interacting with a text-based terminal interface. You'll enter a command like clear. Let's say we want to clear our terminal so we can see a little bit more clearly. Get rid of this login message that's taking up a lot of my screen. And as you can see, the result. In this case, it's all going to be in text, and in this case, it's blank because I typed clear. Now that we have a clear terminal, it's time to get the lay of the land. We can start with something like who am I? Simple command that tells you what user you're currently logged in on, why you shouldn't be able to log in as another user. I'm happy to see that I am logged in as DMDeVry, which is my Unity ID. Likewise, we can enter host name, which shows that we are logged into login03. This is one of the login nodes of Hazel. Like most HPC clusters, Hazel is broken into login nodes and compute nodes, nodes being the actual computers that make up the cluster. Compute nodes are the actual workhorses of the cluster, executing jobs that have been submitted to them through a job scheduler. In this case, we use something called LSF. Login nodes, on the other hand, manage users logging in and basic low compute tasks such as interacting with text files and submitting jobs to LSF. Now that we see what node we are logged in on, we can see what directory we are currently in using pwd or print working directory. Directories are roughly analogous to folders if you're used to a more of a windowed environment. They are the hierarchical structures in which files are stored. In this case, I'm in my home directory, which is the directory that I will automatically arrive whenever I log in. This /home/username structure is pretty standard for a Linux environment, and it serves as our starting point for navigating the rest of the file system. So we can see where we are, but what else is there with us? This doesn't really tell us very much, just seeing that we're in our home directory. If we type ls to list the contents of a directory, by default listing our current working directory, which in this case is /home/DMDeVry, we'll see the contents of this directory. We can see right here the 3 directories, remember they being roughly analogous to folders in blue, 2 linked directories that I've personally set up to give me easy access to my research storage and my scratch space, as well as 2 files in white. Now, like most Linux commands, ls can be altered or modified using arguments or tags, typically a letter following a dash. In this case, ls-l gives us the long format of ls, 1 line per file, giving us a lot of information about each file. It starts off with file permissions and type. In this case, the first character refers to the file type. If it's a standard file, you'll see a dash. If it's a directory, you'll see a D. And if it's a link, you'll see an L. Followed by 3 sets of 3 permissions. R, W dash in this case, refers to read, write, and no execute permissions. This is for the owner of the file, starts with owner, then group, and then everyone else. So in this case, the owner of the file can read it, which is look at the contents, can write it, which is change the contents, but cannot execute, which is to run a program or open a directory. For the group owners of this file, in this case, I am the current owner, DMDeVry, and my group is RFS. Group members can read this file, but cannot write to it and cannot execute it. Likewise, people who are not in my group, but who are logged in on the cluster, can read it, but cannot write it and cannot execute it. Next is the number of links associated with the object. I wouldn't worry about that right now. We have the file or directory owner, the group associated with this, so you can have different permissions for the specific owner versus the group owner. The size of the file in number of bytes, the date last modified, and the name of the file. You can use multiple tags in a single chain. For instance, if you do ls-lh, this makes it human readable, H, which changes the file sizes to kilobytes, megabytes, gigabytes, etc., rather than all in straight bytes. You can see that these directories have now changed to 4 kilobytes instead of 4096 bytes. You can also sort, in this case ls-t will sort by time with your newest towards the top. This can be useful if you've recently spat out a file and you weren't sure what it was named. You can also inverse the whatever sorting is by default by doing R, which does it in reverse. We can type clear again to reset our terminal and move on. So now that we've seen the contents of this directory, let's make a directory ourselves. We can use something called makedir, mkdir, to make a new directory. Let's call it test directory. If we type ls again, you can now see that we have a new directory called test directory within our home directory. By default, makedir will make directories in your current working directory, which again you can access with pwd.
And now you can navigate into your new directory using cd or change directory, navigating into your test directory. If you type pwd again, you can now see that you're within /home/your Unity ID/test directory. A couple notes on navigation. First off, as a reminder, your home is the directory that you enter when you log in. To make things easier, Linux allows you to refer to your home directory in shorthand with a tilde, which is the little squiggly symbol to the upper left of your keyboard. If you type cd followed by tilde, press enter, and then pwd again, you're in your home directory, and as you can actually see in the little shell prompt on the left, there is a little tilde indicating I'm in my home directory. As computer programmers are always about making things easier, you can make your life a little bit easier using tab completion. If you type in the beginning of the name of somewhere you're trying to look or a file you're trying to refer to and press tab, if there's nothing else that starts with the same set of characters, you can automatically fill out the rest of whatever you're targeting. As you can see, I typed tab and it made text directory in full, and I could enter it, and now I'm in test directory. A couple additional notes. You can refer to a directory via the absolute path, which is the true location of the directory, or the relative path, which is the location relative to where you are. For instance, I can enter my home with cd/home/dmdevree, pulling out the entire name of the folder. I can enter test directory using its full name, /home/dmdevree, tab complete test directory. Or I can enter my home and enter it relative to my own location, test directory. Additionally, you can refer to previous commands using the up and down arrows. So if you want to do something that you did recently, there's an easy way to access it. Finally, if you've started to type something out or you're actually running a command that's taking up time, for instance, I didn't include this in the slide, but if I type sleep 30, this does nothing for 30 seconds. Oh no, I want to make this stop so I can actually do something. Type Control-C, and the command ends. This also works if you start typing. Control-C to clear what you're currently typing. So we've made an empty directory. If we type ls, there's nothing in it. Not that useful. We can change that using something called a text editor, a program that allows you to interact with, create, and edit text files. In this case, we'll use Nano. There are a number of text editors available, and Nano is one of the simpler options. And we'll do my Nano, my new script. We can use Nano to interact with the text file however we'd like, entering the text that we want to be in there. For instance, this is my file. It has contents. Following the instructions you can see at the bottom, we know we can exit once we are done using Control-X, which gives us the option to save. We can click Y for yes, and click Enter to confirm the name is my new script. Notice that I didn't have to add an extension. Extensions are sometimes useful for recognizing what type of file you're working with, but they are not necessary in the world of Linux. However, we do ask that you don't include any white space, such as spaces, or any special characters like exclamation points or octothorpes and the like. Just use standard letters, numbers, dashes, and underscores, and dots between extensions. Now if you type ls, you can see there's something called my new script. We can look at the contents of this file using a couple different programs. Two of the more standard ones include cat, which concatenates the contents of a file or multiple files to your screen and puts it directly into the terminal. In this case, cat my new script shows the contents that we wrote. This is my file, it has contents. If, on the other hand, we want to look at, let's say, a longer script that we need to scroll through, we can use something called less and the name of the file. In this case, it opens it up in sort of a separate window. If this was a longer sort of file, we could scroll up and down with our arrow keys, or if we had a mouse, we could use a mouse scroll. We can use spacebar to jump to the end of the page, or jump down a page length, and once we are done, we can press Q to quit. Now let's say my new script isn't very informative. We want to call it something new. You can move a file or rename it. This is the same function in Linux called mv. We enter the name of the thing that we want to move, in this case my new script, and call it instead my old script. Now if we type ls, it has been moved, my new script no longer exists, and my old script does exist. If, however, we want to copy a file, or even a whole directory, and move it to a new location, while keeping its old location, we can do so using cp for copy. For instance, copy my old script to my copied script. We now have my old script and my copied script. We can even copy to other directories. For instance, cp my copied script to home, which we're indicating with tilde, as mentioned before. And if we can just leave it as a slash, and it'll automatically name it the same thing, or we can fill out my copied script. Now if we ls home, we can see my copied script has been copied into our home directory. We can even do this with an entire directory. If we go into our home, ls, we can copy a test directory to copied directory. Notice that it doesn't work. It's omitting a directory because you cannot copy directories without the -r for recursive tag, just as an added measure to prevent you from accidentally copying incorrect things. If we do cp-r though, and ls, you can see that there is now a test directory and a copy directory, ls-ltr. And copy directory and my copied script are both newer than test directory. Now, for the sake of convenience, files that begin with a dot at the start of their name are hidden from typical view. This allows you to kind of declutter spaces, allow them to be more easily assessed visually, while still keeping files around for programmatic use, or for something like configuration. The process to hiding files is fairly straightforward. As I mentioned, just starting the name with the dot does the job. For instance, if we cd into our test directory and ls, you can see my copied script and my old script. Let's say my old script is a configuration script and we don't actually want to see it. We can do mv from before to move my old script to dot my hidden file. And if you do ls, you can't see it anymore. However, if you do ls-a for all, you can now see my hidden file, my copied script, and two new files that we haven't looked at before, dot and dot dot. These are other convenience links. Dot refers to the directory itself, and dot dot refers to the parent directory. For instance, if I do cd dot pwd, we're still in test directory. If I do cd dot dot pwd, we're now in our home directory. If I do cd dot dot here, we're now in /home, which is above my home directory, looking at all the home directories. And if I do cd tilde, we're back in our home. Now, what if we want to remove what we've created? You know, we made a little bit of a mess. We have a bunch of these random tutorial files in our home directory. Let's get rid of them. Well, Linux has a couple options for this. First, and I would say the safest and softest, is rmdir, or remove directory. If we cd into our test directory, and let's say we make a fake directory, mkdir fake. If we do ls, you can see that I now have a directory called fake within my test directory. If I run rmdir on this empty directory that has nothing in it, we've removed fake. However, rmdir only works on empty directories. If we want to remove a file, let's say we want to remove my hidden file, we can do rm.myHiddenFile, ls-a, and you can see that my hidden file is gone. However, rm without any tags only works on individual files. If we want to move something like an entire directory, for instance, if we cd up into our home, let's say we want to remove test directory or copied directory. If we do rm test directory, doesn't work because it can't remove a directory by default. However, if we add -r for recursive, and this is a common pattern, you'll see a lot of commands, if they have a -r, this makes them recursive, which allows them to affect entire directories. If we do rm-r and list, we no longer have test directory. We can add a few tags. For instance, rm-rvi would be remove recursively, verbosely, which is to say everything that is removed, and interactively, which means to check before removing anything. Oh, ask to descend. Do we go into copy directory? Y for yes. Remove regular file copy directory. My copied script. Yes. And it tells you that you've removed it. My old script. Yes. And we'll say yes for this as well. Now if we do ls, it's all gone and we saw everything that was deleted. One other tag you can use is -f, though I'd be careful about this one. This one allows you to remove files that you have ownership over if they are write protected. This is most commonly something you would do if you have root on a system, which is not the case in HPC, but can be useful if you're trying to delete something you know needs to be deleted and they have a bunch of write protected files just by default. While HPC keeps pretty up-to-date backups, I'd be very careful using RM. Make sure you're deleting exactly what you want to delete because it's not easy to take back, if possible at all. As we've seen thus far with things like hidden files, there's a lot going on under the surface when you're running in a Linux environment that help this thing function. One of the most prevalent parts of this are environmental variables, which are just dynamic values that can be assigned to affect the way programs run in a system. These are typically assigned for you specifically, though there will be a number that are shared with other users. You can list all the currently active environmental variables using printenv. This is a lot of information, and not all of these are super useful to you. And we'll clear this out of our way, but a few of note that you can spit out using echo, which shows the true value of a variable. Echo hostname shows that I'm currently on the host login 02. Echo path shows all the directories that my shell, which is the program running this terminal, is looking for any commands. For instance, something like ls might seem just like a simple command, but what's actually happening is that your shell is looking through your path for anything called ls when you type it, and if you type which before a command, it will tell you where it found it. In this case, there is both an alias referring to ls and automatically adding some coloration for ease of use, as well as the true location, which is user/bin/ls. This can be useful for knowing exactly what version of something you're using. For instance, which python3 shows that I'm using user/bin/python3. Another one, echo/user, shows that I am dmdevry, which you would have seen with who am I. Echo group, on the other hand, shows you your primary group, which in this case is RFS, which can be useful for managing permissions. And echo shell shows the exact type of shell you're using. There are slight differences to how different shells run even within the same Linux environment. In short, if something isn't behaving the way that you expect it to, environmental variables are a good place to start checking. There are some final notes that I'm not going to go super in-depth on, but that can kind of show you the potential for utilizing this kind of text-based interface. It might feel clunky at first, but there's a lot of power behind it. For instance, history can be a useful one. If you've run a bunch of commands recently and you don't remember exactly what you entered, history gives you a list of the last X number, often set to 500, though this one seems to be longer. If you type exclamation point and a number that you see within history, for instance, exclamation point 713, we'd expect it to run echo hostname. And in this case it does, it runs echo hostname and shows you the output. Man is manual. For instance, if you're trying to figure out how to use a command or you think a command could do something and you're not sure, man ls, for instance, will open a manual page on ls that shows you what it does and all of the potential tags you can add. As you can see, ls has a lot of options. Press Q to quit. grep is a search tool. For instance, if we ls what we're looking at here, let's say we have a really, really big directory with a ton of files in it and we want to search for text files. We can use a pipe, as seen below, to ls pipe the output, which spits the output into a new command, grep txt. And you can see cronetest.txt pops up, correctly searched for. htop is a useful way to take a look at the system and see if something's not running the way it is. Maybe the system's overloaded. It's not easily viewed in this kind of condensed terminal I have to the side here, but you can see all of the cores that are currently running on the computer. We have 32 cores, and the memory taken up is 11 out of about 188 gigs, so the computer is clearly not very overtaxed right now. Redirecting your output, for instance, if we do echo path, add this redirect to redirect our output to a file, for instance, path.txt. You can see that you've now made a file called path.txt, and if you cat path.txt, you can see that you've saved your path that you had before as a text file. You can follow up a redirect expression with 2 greater than sign and 1 to redirect your error and your output to the same place. For instance, if we try to remove a directory, let's say jobs, but we don't add the -r tag, it normally wouldn't work. If we redirect to out error.txt, and then we add 2 greater than and 1, you don't see that there is any issue because all of the error and all of the output were redirected to the same place. If we do ls, we can see that we have something called out error.text, and if we less out error.text, we can see that it cannot remove jobs because it's a directory. So that is a review of basic Linux. We went over how to interact with and navigate a Linux computer system. This is a very high level, kind of basic introduction, and if you're completely new to Linux, you might want a little more information. If you'd like to get fully comfortable in a Linux environment, I personally recommend Ryan's Linux tutorial. This is a great kind of, I think, 10 module text-based web tutorial that allows you to really get comfortable with Linux environments, slowly introducing each step and the various concepts that you're interacting with so you can start utilizing them for your own purposes. However, we have other options that you can look through under documents/hpclinks.php if you'd like some other options for introducing yourself to Linux. As a reminder, after this video is over, we ask that you read through in its entirety our acceptable use policy at hpc.ncsu.edu/about/aup.php. And of course, if you're listening to this video, you're most likely going through the 4-part series on an introduction to Hazel. Your next video will be file transfers and storage on Hazel. Thanks, and have a great day.